Mr. T says he's teaching you scratch hacks, but what is he hiding? Why isn't he telling you the sinister secret behind his YouTube channel? There are no hacks.
I thought I was gonna learn how to hack into Scratch's mainframe and learn their vulnerabilities, but all I got was a tutorial on how to move a sprite from one side of the screen to the other. Seriously?
After a year of making YouTube tutorials, Atomic Studios hasn't published a single actual scratch hack, and viewers are starting to notice. Around the world, kids are protesting against this travesty and demanding that...
Andy, what is this supposed to be?
Why, it's my TV commercial project, Mr. T. You weren't supposed to... You can't call your teacher a liar. Look, you're the one who named his YouTube videos Scratch Hacks. I'm just asking questions. Where are the hacks, Mr. T? Where are the hacks?
Okay, you win, Andy. Come to Scratch Club at lunch and I'll show you some actual hacks.
Then detention. Oh man, I'm being persecuted.
Yo, listen up. Here come the hacks. These are actual hacks. These are actual hacks.
Resizing objects looks like a pretty basic task, but the makers of Scratch don't make it easy. I'm trying to create an extreme close-up effect for my latest Andy project.
Don't do it!
But if I enter 400% into the size dialog box, Scratch overrides my command and sets the size to 161. No matter what number I try, I can't get past this size limit. The limit is a different size for every sprite you try. Scratch Cat's maximum size is 540. Gobo here can only resize to 497. These size limits seem random, but there is a pattern. Big sprites, like this food truck, only allow you to resize them a little. Smaller sprites, like this apple, are much more flexible. If you take this idea to its extreme and draw a sprite with 0 pixels, there's literally no limit to how much you're allowed to resize it. So the trick to getting large sprites to grow beyond their size limit is to fool them into thinking they're small. Back in our Andy sprite, let's create a new costume that's totally blank. In our code, we'll switch to this infinitely resizable sprite, then change the size, and then immediately switch back to our original costume. If you use the same switcheroo technique in a loop, you can gradually make your sprite grow to enormous size. We're still not zooming into Andy's face the way I want to though, so I need to correct my zoom by moving the image down a little every time it gets larger.
These are actual hacks.
Now that we've learned how to bust through Scratch's size limit, there's one other frustrating boundary we need to break through. And it turns out the same size hack technique can help us here too. Scratch was designed to be kid-friendly, and one limitation the developers added to keep things simple for kids is that they made it impossible to lose objects by positioning them right off the screen. No matter what you try, a tiny slice of your sprite, usually about 15 or 16 pixels wide, always remains on the screen. Like with our previous hack though, size is important. I've sent these 3 elephants charging towards the right edge of the screen. All 3 of them reach the right edge at an X of 240. The smallest elephant can only move 10 more pixels before it hits its movement limit. The medium elephant keeps going until it hits its own movement limit, but the biggest elephant can keep going another 50 pixels before it finally hits its limit. So the bigger we make our elephant, the farther it's allowed to move off the edge of the screen. If we use our size hack to make our elephant ridiculously big, now we can give it a ridiculously big x-coordinate. Let's go with 500. Here's where the magic happens. Now let's shrink the elephant back to its original size, and suddenly it's gone. Scratch is still telling me the X position is 500, which is right about here on my title screen. To confirm that, let's tell our elephant to make a sound when I hover over it with my mouse cursor. And there's our elephant, in a position that should be impossible, right off the edge of the screen. This technique is really useful for any project where you want your sprite to completely leave the screen. But one outside-the-box idea that a few clever Scratchers have tried is making projects that can synth.
You know you love me.
Whether you've loved or favorited them.
I am the champion.
All you need to do is create a sprite roughly the same size as the heart button on the Scratch project page. Now let's use our size hack to position it below the bottom left corner of your screen. I position my love detector at an X of -220 and a Y of -200, which works great.
You know you love me.
One warning though, Scratch can detect where your mouse is hovering, but it can't detect clicks outside the stage area.
These are actual hacks.
I've tossed one last hack into my latest Scratch project, and like the others, it lets you do something in Scratch that should be impossible. When I move my cursor up to the top of the screen,
Don't do it.
Andy warns me not to stop the program. I've positioned an invisible sprite underneath the stop sign that will trigger Andy to start freaking out if it looks like I'm going to press a button.
No!
If you haven't seen this hack before, here's the part that will blow your mind.
No!
If I actually do press the stop button, the script keeps running, and Andy shames you for trying to stop him.
I told you not to press it.
This hack works by taking advantage of a quirk in Scratch's built-in timer. You can check Scratch's timer by clicking this checkbox in the light blue sensing blocks. There's no actual start or stop button for the timer. It starts running when you load a Scratch project and keeps running even after you press the stop button. The one thing you can do with the timer is reset it back to 0, which you can accomplish by pressing the green flag or by activating this block. Let's set the timer to automatically reset itself to 0 every time it repeats this loop. Our timer wants to tick forward, but it's constantly being held back until I press the stop sign. So now we have an event that only starts after our program ends. This event block waits for our timer to get larger than 0 and then runs the code that's attached to it. Like magic, our program starts after we've told it to stop.
These are actual hacks.